This is my bike, yeah. For the LTS transporter, so everything that you see standing down there fits actually on the bike, and I can still drive around. It's a bit uncomfortable, I admit that, but you get around. Conserving energy, how can we do that? If we would replace one incandescent light bulb with the LEDs in every US household, and sorry about the US numbers, you can take out away one of those boxes. Yeah. So one nuclear power station, just everybody should replace one incandescent light bulb with one LED. And don't just take out the ones that still work and replace them, because they need the energy to make them in the first place. Other simple ways to conserve energy, no standby. If you have a TV that's on standby, some of the TVs require more energy than your fridge, which is ridiculous. So take them out of the plug. Standby is really, really bad. Plastic bags are nothing else but oil and energy. And it's found out about Ontario, there's a daily use of 8 million plastic bags a day that we use. Oh wait, lifetime, 300 years. Usage time, 3 minutes. And Ontario has a plan to cut that in half in about 5 years. Let's see how that works. We don't always need a new mobile phone every 3 years, or every 2 months, I don't know, or every often. I don't have any. Anyways, this is our fuel cell research, so this is what I'm usually going to talk about, how fuel cells work. And I need you to have this information, so I'm going to go a little bit into the details of this.
Just so you know, I actually did a fuel cell activity at the OCE conference. But there were like 15 workshops and everything about workshops. Fuel cell
Okay, now listen to this. You need it. You need this for the next activity. That's why I'm going through this. So here we have our fuels, lots of different molecules coming in. And that can be any fuel that we have. Methanol, ethanol, methane gas, any kind of, even petrol products, hydrogen. We need to take away the carbon monoxide. They don't like the filters don't like it. And we end up with hydrogen. Hydrogen is nothing else important. This is this. It's proton and electron. So we split them up into protons and electrons. The protons can go through our fuel cell. The electrons make our energy. Yeah? Protons to the center, electrons somewhere else. Will be important in a second. On the other side, there's oxygen waiting, and they love each other. And they're just going to marry. And we form water and energy. And that's sort of what the fuel cell really is. You split hydrogen into protons and electrons. The protons go through the central electrolyte, and on the other side, there's oxygen waiting, and we form water again. So, and that's what we have here, and that's what I usually show. I either have a car, and I don't know, maybe the airport guys took it out because it looked like a bomb. There's a small container on here that's water, and you can fill it up with solar energy. It takes about 5 minutes, and then you can have kids races. So we have about 4 of these cars, and then they can stand there, and then the car drives around. There's nothing else in these cars but water. But it's sort of vanished between Vancouver and here. Anyway, this is one of the props that we have. The other one that I show around is this. That's a direct methanol fuel cell car. So we have methanol here. It's nothing else but really bad wine. Really, really bad wine. So this is what gives you the headaches in the morning. It's not really effective. Not a big bang. It's not a Rambo activity, but you sort of see a little wheel turning there if I push it a little bit. And it goes to show that we don't only have one fuel, we can have several fuels that we can sort of power our future with. And that's more likely what's going to happen. We don't have oil or cheap oil available anymore, so there's lots of different things that we're going to be using. Why do we have it at the moment? It's too expensive, it's not reliable enough, it doesn't take long enough, and public perception. Remember this guy? It's called Hindenburg, exactly. Actually, 35 of the 37 people who died were the ones who jumped out. Everybody else just wrote it down and then ran away and survived. So, there you go. Talking about flames, this is what I do to make things cheap, and I'm just going to show you this. It's pretty cool. This is the technology that we use in our lab. It's called plasma spraying, and it's about 25,000 degrees warm. So don't stick your finger in. This is how it looks like. So we start out the flame, it's called plasma spraying. And now we start our powder. And now we are at 25,000 degrees. Let's film two very dark screens, by the way. So we're not supposed to look inside into it. I mean, in the video it's good, but not in reality. Usually show a couple different things that we do, and then when we tour our lab, that's a cool thing. All kids are doing. They're not holding the torch, they're standing outside looking how it looks. I'm going to play. Oh yeah, and now we come to you act. Okay, so I usually develop kind of sort of nutcases, and I'm really happy I was able to be here and have a very nice conference with you, and I think you are the perfect audience for my newly developed activity. Let's see how it turns out. In 2006, I developed something that was determined a fuel cell component by the Perceptive Association of Sound workshop. So I just played a couple of songs and then let people tell me if they thought it was the anode, the electrolyte, or the cathode. So there was a little workshop related to that, and then they just had these rap songs and they had to tell me why it's the anode. So that was an interesting new idea. 2007, we had the slightly chaotic play out of a fuel cell on the stage. So we had people play out fuel cells. And now we premiere Canada's next top science object. Okay, I need 3 groups, 3 people. So I'm just gonna. Anybody wants to volunteer? So just pick people. All right, then number 1, number 2, number 3. Okay, come up here. You do group number 1. Once a year, I tell you what you're going to do. Then you can't escape me anymore. There will be a second and third group, don't worry. Alright, so, since you all know how fuel cells work now, in the very quick, super fast presentation, I'm going to read you some lines, and that's something the Lars Science Partnership Program with UBC developed haikus that we sent off to the CBC Literacy Awards this year. Didn't get anywhere, of course, but it was a very nice thing. It was haikus about fuel cells. So I'm going to read you the lines, and you will be acting them out. Alright, let's see how that works. While I read it, you act it out. And then you'll hear some applause from those guys. There will be two stanzas. Alright, group 1. Hindenburg has shown explosion in the dark night, dangers of the age.